Hey folks, Nathan here. We've got a pretty short video this time, looking at how plastic cups like this could potentially be used for cushioning the impact of a rocket as it hits the ground. Spoiler alert for the video, doesn't work. But we'll get into why it doesn't work and what we possibly could have done better. Our goal is to create what's essentially the same thing that a crumple zone is on a car, only on small scale with one of these. So to prepare this one, because it is quite stiff, we put some strategic cuts in here to try and make it a little bit more easier to crush, and then we attach it to the nose of the rocket. In theory, what should happen is that rather than the rocket just hitting the ground instantly and all of that force transmitting at once, what would happen is that this would crumple when it hits the ground, so that as it crumples over time, it's going to spread the force out so that at any one moment in time there isn't as much force acting on the rocket as there would be with a regular collision. The build for this one was pretty simple. We just get a nose cone of a rocket, we put some liquid nails around the outside, and we get our cup. We attach it, and then this will get stuck on top of a rocket, which will then fly and, in theory, land. This will crumple as it lands, and in theory, the crumpling of this should slow down the rocket and stop anything from actually breaking. So with that explanation out of the way, let's take a look at how things actually went. Launch 1 of Crunch Protection Rocket in 5, 4, 3, 2, 1. Oh shit, that went that way a lot. Huh. Alright, Crunch Protection 2 in 5, 4, 3, 2, 1. Well, that came off. Not bad. Launch attempt number 3 of Crush Top Rocket, launching in 5, 4, 3, 2, 1. Excellent. Alright, our analysis of what happened. So with our first rocket here, we can see that it survived pretty well. All the fins are intact, the weight is still secured by the Velcro there. And if we look at the cup, we can see that it is very heavily cracked. It didn't crumple, but we can see that there was a lot of force that was absorbed by it, and that's just completely taken out one side of the cup there. One thing I didn't anticipate was the aerodynamics of the cup, or rather the lack thereof. So looking at this, it's a very flat top, so there's no rounded edges to it. So the moment that it sort of moves slightly off axis, the air is going to push it more this way, which means that it's going to fall on this sort of angle. And you can see in the video that sort of as the rocket's falling, it's sort of going down on an angle like this. And that's mostly, I think, because of the cup aerodynamics not really letting it fall straight. Launch number 2, it couldn't be seen in the video, unfortunately, but just after launch, the nose cone fell off because the liquid nails weren't really set right. So that just meant that it was a regular ballistic impact into the ground. Looking at launch number 3, we can see that the cup was just split top to bottom again. We lost a fin, and our payload in the nose cone there, which was just a rock that was liquid nailed in, was completely dislodged. So that suggests that the cup wasn't dissipating enough force, and anything, if we had any sensitive equipment inside, would have been broken on impact. This has shown that at the very least, a cup like this is not suitable as a crunch protection for a rocket. I do think that possibly a weaker cup, like a paper cup, might help a bit more, especially if you filled the inside with something that compresses well, like scrunched up bits of paper or something like that. I reckon for a model rocket of the just plastic water bottle variety, I reckon you could do a pretty good job there of dissipating that impact and having a pretty safe landing. One thing I definitely did learn from this though is that wherever possible, I should be trying to test things before putting it on a rocket. So what I did with this was I had my theory, I just chucked it on a rocket, I flew it, it crashed, it didn't work, and as a result of that, the rocket got damaged. So I can do that with these small model rockets, but once I start getting into more expensive things, that's not going to be feasible. So I think definitely I'm going to have to, where possible, test things off the rocket first before testing it on a rocket. There's obviously going to be some things that you can't test without being on the rocket, and for those, the rocket's just going to have to do, and we're going to have to hope that it works well. But yeah, something like this, I could have like just chucked it on a desk and dropped things on it that are roughly the same amount of force that a rocket would experience when it hits the ground, and seen if that broke it or not, if it crumpled or anything like that. And then I would have known before putting this on a rocket that the idea wasn't feasible. So moving forward, we're going to be doing as much off-rocket testing as we can before actually doing things on a rocket. And we'll hopefully be showing that process. And that's it for this video. Catch you later.